So just out here camping on some islands, figured I'd show off my solar boat conversion. So I see a lot of YouTube videos of people making or converting their boats over to electric, and they don't really have a lot of videos showing what happens down the road. Now I didn't ever do a build video or anything like that. I don't think to do it while I'm building stuff. I'm not very good at that. I just build and just kind of fly by the seat of my pants and then just kind of get it done. But now this one's been thoroughly tested. We're out camping on islands. It's got okay range. Obviously solar you never have as good as just filling up with gas and just going, but it's got solar. We're able to charge pretty good with the amount of solar panels. I've got 8 250 watt solar panels, and I've got basically 2 sets set up in series, 4 in series, and then the 2 sets in parallel, just to get me up to more voltage. But that's not the important part. The important part is the actual conversion, and then just kind of numbers what I'm able to do with this boat. But it's converted tri-hull. It's a 22-foot tri-hull that I have modified multiple times over the years, mostly for using for crabbing in the Pacific Northwest. Nothing too aggressive. Rocks a lot being a tri-hull, but generally it stays upright and it's pretty stable. Good platform for putting a lot of solar panels up high, adding some height to it because of it being a tri-hull. It handles the weight. Each panel by themselves weighs 45 pounds, and you get 4 of them up there. And plus the framing that I made it all out of aluminum. Tried to make it as light as possible, out of sheet and tubing. Pretty quick, just pop riveted it together, holds the weight well, nice and stable. But we're able to usually generally charge the 48 volt system at 25 to 30 amps generally consistently. But we'll get more into numbers a little bit later. But as you can see the boat here, it's just a big open deck, lots of space. We got a bilge down here and through the grate, so all the water that we bring on board when we're crabbing just goes right down in there. It keeps it really nice, keeps a dry deck. I'll go into how I made them, but I've got my battery boxes here. Each one of those is a 48 volt system. They got 4 12 volt lithium iron phosphate batteries in them. And I'll go into a little bit more on those. And then over here we have the controls, which I didn't buy a fancy set of pre-made electric speed controller, marine style. I just used the original set of controls from the converted foot from the outboard. I'll go into a little bit more details why I specifically chose that one and what motor setup I did and everything else like that. So I'll go ahead and start showing you guys all the little bits and pieces all around throughout the boat, and hopefully answer any questions that people have. So first, starting out here in the rear, obviously the main drive unit here. Looks a little goofy, I know. I've got my nice little Husky tote right here. I use these totes specifically for things all throughout the boat. They're not that expensive. You get them at Home Depot, and they're, for the most part, pretty watertight. Obviously, I've never submerged one and see how well water stays out of it, but I've hosed one down pretty heavily, as if it was a heavy rain or a splash. And it keeps a lot of water out because they have this nice rubber seal all the way around, nice squishy rubber seal. It's got a lip that it seals really good on, and it latches on all sides really, really well. And they do have clear lids, so you can kind of see what's going on there. But a modification that I'm going to talk about doing, that I'm going to change about that specifically, the clear lid has its positives and negatives. So as you can see, it's just the foot of an outboard. It's actually started its life as I think a 1975 Johnson 50. So it's specifically, I like these ones because they have the electric shift. They call it the hydroelectric shift. It's nice because it doesn't use a stiff cable. You can see I don't have any stiff cables or anything going to this whole goofy apparatus that I have going on here. But for straight up, it's electric shift. The electric motor inside only needs to spin one direction. It keeps it really simple on the controls. It's just 2 little wires that go right inside here. It has 2 electric solenoids down the lower portion. I've never had any issue with them. I don't know if they have any inherent failures or anything like that, but I for the most part, I've seen they're pretty reliable. I've ran 3 of these different motors, never had an issue with the shift. Always had any issues with the 2-stroke head. But generally with the foot, as long as the gear oil is maintained on it, I've never had an issue with it. So basically then going up, I've installed a brushed motor on it, mostly just because that's what I had. A lot of this stuff I had. I don't, for first testing things, I'm not going to go out and blow a lot of money on it. But I picked this up, Facebook Marketplace purchase, just picked it up real cheap. I believe it's the ME1004, I believe. I'll look up the numbers and put that on the video for people to know. But it's about a it's a 20 kilowatt motor equivalent, so probably pretty somewhere around there in the 20, a little bit more horsepower range at max power. It really is only capable of doing about 10 kilowatt continuously before it starts to get too hot. But I think it can do a 1 minute burst of 20 kilowatts. But generally, I don't even get close to that when I'm running at. But I see it just keeps it simple. 2 wires. I don't have to have a really fancy speed controller or anything like that. It does cut down on capabilities that I could do, but generally, one direction is all it ever needs to spin. Is because this foot, once again, has the hydroelectric shift, and then and that's all in the shifter and the speed and the throttle up front. That switch is in there, so when I pull it back to neutral, the motor is off, and when I flip it to back, it's already shifted into gear before the electric motor starts spinning. One reason that one thing with this specific foot, I don't know if it's the same for all other foots, I haven't taken too many apart, but you actually cannot run it in reverse via the electric motor. The reason why is because the shaft going down into the foot, down to the spur gear, down in the bottom, is threaded in. And if you spin it too hard in reverse up here, it'll spin that shaft right out and you won't have any power going to your bottom. I don't know if people have had that issue. I've seen a lot of people set up the reverse through the motor, and I've wondered if it's given them any grief. But you in this specific foot, you cannot run the motor in reverse. It will disconnect the shaft. So you have to use the shifter from this, which keeps it simple because that allows me to purchase a much cheaper speed controller or motor controller, keeping this whole project simple. Obviously, if you're ever testing anything, always take a little extra kicker motor with you just in case it dies, but this thing hasn't given me a single hiccup. I haven't had to modify it or anything. First build, I quickly slapped this tote on here. I plan to build a better cover that's more fitting. This is just something that was quick, it worked, and it keeps the rain out. And then I do have some cooling set up because it is an air-cooled motor. It has a slight little bit of its own fan, but it's not that aggressive. So I have an extra little duct fan that's in here that goes through this tube here, and it blows air in, and then hot air can escape and go back in. But also wiring is going through this tube as well, as you can see in here. So you can see those 2 ducts there. So one is blowing directly on the motor there, and the upper one is where the hot air kind of escapes. If I'm running at a certain high draw for a little while and the weather's nice, I just take this cover off and just let it run out in the air. But generally, most time, because they closed, it runs quieter, and it keeps it plenty cool at the amp draw that I'm usually running at. This used to be an inboard boat. Used to be IO. Used to come through. You can see I have a board right here plugging it up, but then I just quickly had manufactured this rear, what would you call that? I guess outboard mount or transom mount. I just kind of fabricated that up real fast. It's been working. I'm going to rebuild it eventually, but for now, it's the way it is, and it works. Now, stepping back in the boat here real quick, coming down here, right mounted to the inside of the transom and the stern here is the hearts of the electronics. Once again, another one of these Husky totes. It's a shallow one. It's not as deep, but you can see in here, I have my All Tracks motor controller there. I believe it's the 500 amp version with its own cooling fan. I don't think I've ever ran it hard enough to even for its own cooling fan to turn on, and it doesn't really run hot in here. I had concerns that being sealed up in this tote here, strapped to the wall, that it would have cooling issues. Once again, I just don't run this boat at high enough draw for what I'm using it for to require any more ventilation. I was planning on putting another duct fan going into here, but it wasn't necessary. And then I can keep it real simple, going straight from the speed controller right to the motor. But I have my contactor here, which is controlled, which clicks on when I activate the throttle. And then I have my, I believe it's a Victron amp or draw monitor. What's the technical term for that? I have a meter up front. That's for my amp meter up front. It's a Victron. I don't know the exact model. I can put that in the description if people are curious. Down here, I've just got a real El Cheapo battery charger for specifically my 12 volt system. So I have just an individual lead acid 12 volt battery that for running lights, the shifter specifically on the foot requires 12 volts. But anything else that needs 12 volts on the boat, any other gauges, lights, etc. This keeps that battery topped off at all times. And I already had, it's one of those things, I had it, using it. It's got its own cooling fan. This one specifically, I've heard if you use it hard and heavy that it gets hot and will catch on fire, but the thing hardly works at all, just keeping the 12 volt battery topped off just for very little draw. But that all keeps it up, sealed up in there, away from any salt water or any moisture at all. It's got some holes in the bottom of it where the wires go out there and there, but I've tried to keep them small and keep airflow down to keep moisture out. But so that's basically how we drive the motor. Now to the battery boxes. You can see they're just the Husky boxes once again, just with some batteries and padding jammed in there and some contacts. Now, obviously for safety, those are not wired directly just straight up to the batteries. I have breakers in each box to be able to, in case of emergency or in case of a short, they will disconnect. I believe they're 300 amp breakers. I can see there's a little water standing here. We had a little bit of rain this morning. But this keeps the inside the battery boxes completely dry. We're rocking in the waves here. But right here you can see I have a 300 amp breaker. It's nice that I can be able to turn this battery off before disconnecting. Don't have to worry about crossing leads or anything like that. But you can see the battery that I'm running here, just a El Cheapo lead time. And they do the trick. They're 100 amp draw, so I'm able to, with all 4 of them ran in series, that's still 100 amp draw at 48 volts. But with 3 of them all together, that gives me my 300 amps that I can pull at one time, which is more than I ever need for what I use this boat for. Changes that I wish I will make on my next future boxes is, this is a waterproof breaker. I put it in here just because to keep it as safe as possible from salt and all that stuff, but it is a pain in the butt that if I have these battery boxes stacked, which sometimes I do stack them, I can't get to the breaker to turn them on or off without unstacking the boxes. So in the future, they're going to be mounted right here on the outside. Another thing is putting the contacts so close together. There's nothing, I mean, you dropped a wrench, you dropped a screwdriver, it goes across those 2 contacts. Yes, the breaker on the inside will pop, but you're gonna get some good sparks when it does it. And you're also gonna lose this battery bank until you can reset the breaker. So over here, this was the very first box, way too close. And as I went through the making more of them, I spaced them out. But I wish I had put them all the way at the far corners, just for safety. Or if anybody has any other creative ideas on how to mount those, that'd be great. But I just use stainless steel bolts going through, and these are just copper crimp ends on that. So nothing super fancy. Once again, these are 1/2-inch bolts. They're stainless steel. They never even get warm. I don't ever pull enough power out of all of these to heat those bolts up enough. I have them on, I got rubber washers on there, so it's fully watertight going through there. it's just it doesn't ever get hot enough to even feel warm to the touch. But right now, I nothing else I can really say much about the batteries. Just got a bunch of padding in there so they don't rock around in there. They have air gap all around them. If any of them need to, if for any reasons need to swell up or anything like that, they have room with the foam. And then also just keeps them somewhat insulated from the sides, so that way if it is in freezing temperature, which sometimes we do crab in that they do stay a little bit warmer in there and they're not completely exposed to the cold weather as much. But it gets a little crammed back here in this back corner, so that's why I like to make them so they're stackable. That's the nice thing about these totes. Once again, they stack, lock in, handle the waves just fine, allowing us to have all this deck space here for doing our activities. Right here is how I convert the old motor throttle into an electric one. I've got the cable, because it only has a single cable coming out of those remote controls for this foot. It's just a throttle cable, so that I have that going in here and sealed. And let me pop this open for you real quick. But in here, I have the basic El Simpo throttle that you get for an old style golf cart or anything like that. Just a 2-wire potentiometer. It has an extra potentiometer in there for a different kind of golf cart or different use, but I'm using the one rated that goes out and goes back there to the speed controller. And that's basically how I convert the mechanical throttle into an electronic throttle. And that only needs to go basically it's forward all the time, because the shifting is in the rear, not dealing at all with any kind of reversing contactors. Keeps it simple. So when the solar is not cutting it, we're crabbing at night, or it is just too cloudy, too rainy, that we are not pulling enough power from the solar, that 300 amp hours of battery just isn't cutting it for us, we do have the backup generator. Now, this is an experiment in itself. It was successful. It does what it needs to do, but it is a Frankenstein of a generator. So this was an attempt to create a DC generator. Now, this is not just a standard generator. This is one of those inverter generators. The big difference between the inverter generators and a standard generator is a standard generator will not have permanent magnets. It will use an electromagnet for the rotor in the actual generator head, and that needs extra power added to it. And that's how it regulates how much power it puts out. Generally, the gas motor will have its own mechanical governor on it that keeps it spinning at a specific RPM, and then the generator head on a standard generator will regulate the voltage going to the electromagnet on the rotor to control how much power it creates. Well, you have brushes and all kinds of stuff in there, salt water, all those. Probably not a great mix, but I mean, I have brushes in my motor right back here, but I figured I got this free generator that the inverter controller was fried. So I figured it was a great opportunity to go ahead and turn it into a DC generator. So once again, it has permanent magnets. I don't have to add any power to a rotor to create the power. Keeps it super simple. As long as this gas motor spins, it creates power. It does create AC, and it creates up around 250 to 300 volts AC, which was a little bit of a problem, because converting that into DC, I had some problems with that, because the having 300 volts DC, I didn't have a solar charge controller that could handle that amount of amps. At least for an affordable price. So I needed to reduce how much power it created. So I changed some wiring on the coils, changed it from a Y configuration to more of an individual configuration. Instead of having them all wired together, I have each individual coil, because there's 3 sets of coils in the generator. I have each individual coil going to its own rectifier. So each of these, let's see here, these wires coming out of the bottom of the generator right here, each one of these is one of the wires from the coil. So it's set up, I believe, in the Delta configuration. Actually, no, I don't believe it's set up in any of those configurations. It's just set up, wires come out, 2 sets of wires go into these, each end of the coil. AC goes in, DC comes out, and then I have all of these running in parallel. It ends up giving me around 150 volts by reducing it to the individual coils, but it does the trick. The other problem to solve on this generator, other than just trying to get a low enough voltage out of it to use for the voltage the charge controller, is the motor, the gas motor controller. So in these inverter controllers, they have a computer controlled throttle. It's not a mechanical controlled governor, it's an electric one. So when the inverter controller died, that also controlled the stepper motor on the throttle for the gas motor. So and a quick fix for that is my own little Jimmy rigged electronic system. So here I have the electric start button that I can electric start the generator. I have the kill switch here, and then this switch here turns the stepper motor controller for the throttle on or off. Unfortunately, it's not automatic. I have to manually control the throttle by going up or going down on the throttle. Eventually I want to go to a toggle switch to make this easy, but these are just momentary contact switches. They're what I had. Once again, doing this as cheap as possible for the initial test. But eventually I want to go to an automatic one that regulates the RPM based on the voltage. I plan to just use an Arduino board and learn to write some code and go ahead and program it to run off the voltage coming off of the actual head, that it keeps it regulated at 150 volts, and it will control the RPM associated just as a normal governor. Because luckily, when I set the charge controller and I set what specific amperage I want, as soon as I turn on the charge controller remotely using Wi-Fi, I have to be right here ready to push the button to move the throttle up to maintain. As the draw increases, as the amperage comes up, I've got to be here ready to bump this up. And if when I turn it off, I have the same thing. I have to be here ready to bump the throttle down, otherwise the sucker revs high sky up. Yeah, all the way red lines. Luckily, it's got its own built-in rev limiter. It has a full electronic ignition. That saves me on blowing the engine, but it still will rev all the way unless I'm here to catch it. So that is, I've thought about moving this whole box up front. I've got plenty of dash space, as you've seen. It'd be nice to be able to control the whole generator from up front, but it's just for now, it's back here. It's only when I need it. I don't use it every time I run. It's usually only when it's cloudy or at night. But it is a quieter generator, but still, I went through the trouble of piping the exhaust out the back of the boat through an exhaust flange. And it's just tied into the exhaust there, and I did plenty of length to keep it cooler, but it just goes out the back of the boat and shoots out right there, and it keeps it a little quieter. It still is a generator. It's not perfectly silent. I plan to build a box and a cooling fan and everything for it to make it quieter, but for now, this is what we got. Coming up here to the Helm, up here, super duper simple. I have no need for any fancy gauges except for this gauge right here, which is going to give me all of my specs on how much power I'm using and charging. That is that Renogy gauge that uses that amp monitor in the back, or that's what do they call that? A stunt, I believe is what it's called. But that is giving me all the numbers and everything that I need. I can right now, as you can see, it's charging at 22 amps right now. You can see how many kilowatt hours, how many amp hours I have left before I'm fully charged. We've got percentage of batteries charged, and that's how long I can run with the specific amp draw. This is how much voltage are in the batteries right now while they're charging. and then obviously back to how many amps. That tells me everything I need to know. Now, I usually have an iPad that I place right here that I connect via Wi-Fi to this gauge, and it gives me all of the specs all together, and I have that in a big screen right here. So generally I have this just set for giving me amp draw, and then I have the iPad here that gives me all the numbers about how many amp hours I've used, my voltages, everything else right there. And then I can also control the charge controller itself from the solar system or the gas generator that I have on board, which I'll show you here in a little bit. But let's go ahead and move over here to the controls. You can see it's just this old Johnson hydroelectric drive. And so super easy. All I gotta do is push the button in and move forward. Of course, turn the power on so that you have power to the shifter, but you can't even hear it shift back there. I can just go straight into power, and then obviously back to neutral. And it locks into neutral, super nice. I've seen a lot of the ones you buy for the speed controllers, they don't lock here in the middle. They have a detent. So you can bump the thing. It's really easy to move. This is really nice. It's got the button to unlock it. You have some play, and then you feel where it actually contacts. I can just hear the shifter back there just now, and we can go ahead and go into reverse. And I can go ahead and pull myself back. But it's super nice, locks in when I'm doing driving the boat for crabbing. It's really nice that I don't have to worry about bumping it, moving it when the guys are pulling in the crab pots and stuff like that. But for the most part, I like the view at the front of this. This boat I did convert to have this front helm. It is pretty much the front of the boat. That is it right there. It is right off the nose. So generally, I can see everything out in front of me. When we go night crabbing, I don't want a windshield or anything in front of me. I just need my spotlights that I have in the corners, and that lights up the whole area in front of me. And I'm not blinded by any other deck lights or anything else like that. I don't have a nose light that I'm worried that I can see usually. That it allows me to see the buoys out there really well. But that's the simplicity of being able to use one of these, and then just using the basic plain Jane potentiometer for the throttle control. Now, last but not least, we have the charge system, how to replenish all that power we've been using. So in here, to keep it real simple, we just got two components. Really, one of them's for charging, the other one is just using AC power. We've got a charge controller here. As you can see, it is the Victron. It is the 250 volt, 70 amp charge controller. Sorry, I got some waves here. I'm rocking all over the place. But it is more than adequate to handle when I get any kind of voltage spike from the generator, because I pipe the generator in through one of these breakers. So I've got two breakers over here. One is the solar system. So these wires go up, and so that I can use when it's sunny. And this is when I run the generator. I turn this one off, turn that one on, and these wires here go off to the generator. So it keeps it real simple, nothing automatic, all manual. But so right now we're running off solar. You can see batteries are 53.9, and we're running it anywhere from around 25 amps continually on charge, which charges the batteries up when they're at a full empty 300 amp hours. You guys do the math. That would pretty much be, oh, my brain. Anyways, yeah, obviously math hard in my brain. So that would just be 12 hours of that amperage I could do full charge from empty. But then over here we have the Victron, one of their smaller inverters, just for running power on the boat. You can see here I've got some plugs down here in the bottom that I run I can run cords out, whatever I need. But right now I'm just charging technology. So I've just got basically my battery charger for my tools, running USB to charge my iPad, so which I use for driving the boat around. I do not have a 12 volt plug set up on the dash yet, which I plan to. But yeah, so this is the charge system here, and it does the trick. So to wrap this whole video up, let's talk some numbers. So with electric boats, efficiency is everything. You're not going to be able to compete with a full-blown 100, 200 horsepower gas motor. The amount of batteries that you need is just cost prohibitive for the average hobby guy. Generally, slow cruising. You need to pick the boat that goes best with your electrical system. I did not do that. A tri-hull is like a barge. It has a lot of drag. A tri-hull is designed to get on step quick. It is meant to be stable on the lake and to scoop water underneath and get on top and still be able to steer well and not be completely flat bottom. You have that V center and these two little V hulls on the outside, but generally it's a barge at slow speeds. You're plowing. So generally, if you're creating a wake, you're stirring up water, you're wasting energy. And so this being the first test, just to see if you could convert it to electric, put some batteries in it, throw some solar on top, and be able to have some fun. I was never expecting to go fast, but it's what I had. And it has enough room for me, my family, and friends. But so generally, I'm cruising around 4 to 5 miles an hour. Generally, you know, if you're patient, you can get around wherever you need to go with that. For some people, they want to go 20, they want to go 30. Electric, it's just, I mean, it's not there yet. I mean, batteries, costs, and also just the amount of weight and refill. It just takes too long. Right now, just talk some numbers what this boat's capable of. So when I want to go 4, 5 miles an hour, depending what the wind's doing, 50 amps. I'm pulling 50 amps. That's really not a lot of power. At that kind of pull, I can drive around for 6 hours going 5 miles an hour. Yeah, so I mean, I can roughly get close to 30 miles out of a charge. And if while I'm charging, if I'm getting 25 amps, well, that's half the power I'm using. The battery's actually only pulling at 25 amps. The way I wired it up is the charge controller taps into the power right at the motor controller. So as I'm cruising, that consistent power coming from that is actually charging the motor controller or energizing it, and I can drive cruising around at only 25 amps on just the solar indefinitely, and I'll be going 2.5 miles an hour maybe, but I'll get somewhere fully on solar. Now if this was a sailboat haul or something a lot more longer and sleeker, obviously I'd probably get more speed out of those kind of amps, but this is just not the right pick. It works for crabbing, but getting around to some islands, if you're patient, it's like sailing, slow. And nice thing is I don't have to tack, I can go straight there. Yeah, so like today, mowed around for a few miles. We were pretty much used almost no power. If I have a failure of the batteries for any reason, I can get where I need to go. If I have a failure in the solar system, I can get where I need to go. On a full charge, generally, I don't go more than 15, 20 miles away from where I start, where I'm at. When I go crabbing, we only go 3 miles away from the dock. So this meets my needs. It might not meet what other people want, and you're going to have to spend more money to get the range and the speed that you want. But nothing is free in this world. Everything has a cost. And what I was willing to put out wasn't a lot. Convenient thing is I already had the electric motor. The funny thing is, I already had the batteries. I live completely on solar already as it is. So I just steal the batteries from when we go places. I leave some batteries at home, running the house, and everything we need there. And I steal these 3 banks of batteries. This is how I have the batteries set up at home. So it makes them really easy to disconnect, be portable, and just throw them in the boat, and they're fully charged, good to go, and ready for a day on the water. Yeah, so I mean, the fact that the motor is capable of pulling at 400 amps, I never even took it that high. The highest I've ever gone is 300 amps, and really, honestly, the boat doesn't go that much faster. To talk about some quick numbers, At 50 amps, I'll go 4 to 4.5 miles an hour. At 100 amps, I go 5, like half a mile an hour faster, maybe 5.5, depending on the winds. But generally, for double the amperage, I get 1 mile an hour faster. So I've found that the most efficient amperage for distance on this specific hull design is 50 amps at 4.5 miles an hour. After that, I'm making a wake. I'm wasting energy. Going further, if I jump it up to 150 amps, I'm going like 5.5. I might get to 6. If I jump up to 200 amps, I'm going a little over 6. If I jump it all the way up, say just leap all the way up to 300 amps, I get up to maybe 8 miles an hour. So at 300 amps, which is 6 times the power that I was using to go 4.5, I can now go 8. So for 6 times the power, I can't even go, I'm only going double the speed for 6 times the power. Not efficient at all. Keeping it slow is the way to go. But that's kind of boring unless you're somewhere where it's beautiful and you enjoy the scenery. I like it that it's free. I already had the solar panels, I already had the batteries, I already had the boat, I already had the motor. Really, honestly, the only things I had to buy were the all-track speed controller and the voltage charge controller. That's kind of it. I kept it to a really cheap project. Most people don't have this stuff laying around to do that. So, it would be pretty spendy. Like over $1,000 in solar panels. $3,000 in batteries, $600 in electric motor, and all-track system I think is like $700. That was the most expensive part for me, was the speed controller, and then all the little bits and pieces. You got to throw in probably another $1,000. It can get spendy really fast for a really slow boat. If you're gonna spend 6 to 8 grand converting your boat over to electric, spend 6 to 8 grand on a used, 50 to 100 horsepower outboard that will be reliable and work good for you and get you places. It just eats gas, and that gets expensive down the road. I was blessed to have all this stuff laying around to do the project, and it's nice being quiet while crabbing, and all the power that I need. So anyways, this has been my project, my conversion. I've got probably a little over 50 hours on operation so far, and she's going good without a single hiccup. But fingers crossed on that. Unfortunately, this is not a wood boat. It's fiberglass. I don't have any wood to knock on, but for the most part, she'll keep going. All right, well, till next project, y'all have a good one.